All right, our next Super Six was the telephone lines. This one primarily focused on the probability units. We had discrete random variables. And so you can see we had this discrete random variables because this was the discrete, the exact number of phone lines that were in use during at noon each day. 0 phone lines or 1 phone line or 2 or 3 or 4 or 5. And then you can see the frequency at which those happened. So 35% of the time, only 0 lines were in use at noon, and so on. 20% of the times, 1 line was in use at noon. Now, when you one of the things I need you to really focus on as we go through this is the work to be shown, filling in those formulas to make sure that you don't just plop out a number. That's a definite uh, grounds for not getting your credit is we're not showing what we are doing to come up with these values that we come up with. So here, when we calculate that expected value, that's the mean. Okay, so we're getting that from 0 times 0.35 plus 1 times 0.20 plus 2 times 0.15 and so on. So anytime we had the and so on, I put the first in the sequence up to the last in the sequence, the 5 times the 0.05, and that meant on average, I expect there to be 1.6 lines open or being used at noon. And it's okay to be a decimal because that's on average what you expect to be happening. So I did one variable stats of list one with list two's frequency. That's the only time you're going to be using your frequency list in your calculator when you're computing with your one variable statistics. So how do you expect the average? Okay, so then here we had, now we're going to do 20 randomly selected days. So here's this idea of getting several of them. They found 1.25 telephones were in use. So the staff proposes to select another sample of 1,000 now. So when we select now more, then I think, we're definitely going to have less variability from sample to sample. So a sample of 1,000 is going to be a lot closer to another sample of 1,000 to another sample of 1,000. A sample of 20 will could vary more from this sample of 20. So the samples, from samples to sample, they're varying more if you only had 20 than if you had 1,000. So the means taken from smaller sample size will have more varied outcomes from sample to sample than the means taken from the larger samples. All right, now here is the median. I thought this was kind of confusing how this was written and everything. So I just went on my knowledge that, median is that 50th percentile. So if median is at that 50th percentile, I'm looking up here and I can see, if I had 100 items, then the first 35 of them in order would be zeros. And then the next 20 of them would be ones. So I'm playing along with this and I'm saying, okay, well, then where would that 50th piece of data, that 50th percentile fall? Well, that's going to fall in here somewhere, and that's going to be one of the ones. So therefore, I can tell that the median would be the value 1. So that's the answer. And then I did explain it. Did it safe to explain? But I did, since 35% of the days are 0, the next 20% are 1, then that 50th percentile falls in the 1 phone line is in use. In a sentence or two, comment on that relationship between the mean and the median and the shape. So remember that when we have, if we're comparing the mean, which is greater than the median, then I can tell that it is going to be skewed to the right because the mean is greater than the median. And if you look up here, look at this. This is the 35% of the time, and then the ones happen 20%, and then 15% and 15%. Oh, those should have been the same. And then 10, and then 5. So you can see it is skewed to the right. And there is how I described that. What's the probability that 3 or more? So you're just summing up 15, 10, and 5. and those percentages. And look at the work I showed. Do not just plop out the number 0.30. Put down the numbers that you use to add up. Now we want at least one. You could think of this in two different ways. You are either going to be adding together all of those items there, or you're going to do 1 minus the 0.35, and that will leave you with what's left. Do you remember the 1 minus the probability of none? That's the way you could do that. Now, here comes the conditional. Given that 3 or more phone lines are in use, so that's out of the 30%. Okay, so out of this section here, what's the probability that there was 5? So when you do your given that, it's the 5 and 3 or more, which happens to be this part. So this is the part, 5 and 3 or more, out of the whole 3 or more. So it comes out to be that 0.05 out of that 0.30. So there's 16.67% chance that all of them are in use if you know 3 or more are in use. All right, now we have some binomial or geometric stuff going on. So here we go. Exactly 2 out of the next 5 days. You must show this formula here. What you go and put into the calculator doesn't matter. You don't have to write that down. So this is out of 5 days, I want 2 successes. And this is the probability of having, they wanted no lines, no lines in use. So I'm wondering if I think I might have used the wrong number here. Um, there are no lines in use because wasn't no lines in use 0.35. So I'm thinking that this right here should have been a 0.35 and then 0.55. Assuming each day is independent, with probability exactly 2 of the next 5, there are no lines in use. So the probability I should have been using was the no lines in use. So I need to go and fix that. That'll make this different. It is out of 5, 0.35, and 2. So no lines in use. Okay. Now, next, this one was that all 5 are in use until, okay, what are the chances that you don't find all 5 of them in use? So, not all 5, not all 5, not all 5 until the 7th visit. So, that whole first 6 days are not in use, and that 7th one you have all 5 in use. So here is all first 6 of them are not in use, and then this one was. Now, here is this standard deviation. I got that when I calculated one variable stats of list 1 with list two's frequency. This came up as the standard deviation. Now, you need to fill in this formula though. This is on the formula chart. And I can pull that up here in a minute, or I'll show you that where that is shortly here at the end. I don't think I have that easily to pull up, so I might have to show you that separately on another video. But anyway, so on that on the discrete random variables on the front of the formula chart where it says discrete random variables, there's the mean and the standard deviation, and this was the formula there for that standard deviation. Next, we transformed from the number of lines to number of minutes. So the mean times the mean number of lines is 6 minutes. The number of minutes times the standard deviation number of lines. There was no addition here, so they do just multiply. But here, now, this is tricky. We are combining 7 days worth of the lines. So combine 7 days worth. So that's adding up 7 days. So we can do that normally with the mean, but we cannot do that with the standard deviations. You cannot add standard deviations. We had to add the variances. So that was 0.15 or 1.56 squared is the variance. So I added up 7 of those variances. Also could be computed as this: 7 of the variances. And then instead of leaving it as a variance, we got the square root for the standard deviation. And finally, here we had the original values. I used the original values for 1 day's worth, and I combined them with this mean of 2.1 and standard deviation of 1.8. So here was the means combined like normal, but the standard deviations, you must combine their variances. The variances for the first and the variances for this one, this center. All right, there it was. So I hope that helped you on those probabilities. Make sure you are showing that work to get your full credit and not just plopping out a number. Any number should look naked if it doesn't have the way you came up with that number and the label of the context of what that number is. Good luck to you.